Here's a very quick overview of Amazon EC2 and all the components that make this up. EC2 stands for Elastic Compute Cloud, which is basically the AWS cloud or computing web service. And AWS allows Amazon users to create and manage instances, which are basically virtual machines or servers in that cloud. And these instances, aka virtual machines, are known as EC2 instances. And just like traditional virtual machines, these EC2 instances need an underlying base image, which is known as the Amazon Machine Image AMI. And there are many different types of images you can choose from in terms of operating systems and various config, etc. In fact, there are so many instances for you to choose from that Amazon even groups these into what is known as instance families. So you will likely find one that meets your specific needs already pre-configured in a nice little package for you. And to connect to one of these EC2 instances, aka virtual machines, Amazon AWS provides three default ways, one being the Amazon Web Console, two being the SSH console, or three using an SDK developer kit. And in terms of pricing, I should probably mention there are many different tiers that you can look up in Amazon AWS, but basically most people use pay as you go. You pay for the time that you use on the machines, and when they're turned off, you don't get charged. And this leads us nicely to two important terms, scalability and elasticity, depending on your needs and what you are trying to achieve. These two cloud concepts are very important for your AWS Cloud Practitioner exam and even the CCSP exams. So I have just cleaned up the screen a little bit so we can expand our diagram. So let's discuss scalability. There are two ways to achieve this. You can either scale up or scale out. Scale up is adding more resources to the existing EC2 instance, aka virtual machine, whereas scale out is adding more instances, aka more virtual machines. And thus, the purpose of scalability is the ability of a system to handle an increased load by adding resources, either by scaling up or scaling out. And the ability to automatically scale is known as elasticity, where depending on real-time demand, resources can be scaled up or down automatically. And here's a bonus revision exam tip. Scale up can be remembered as vertical scaling and scale out can be remembered as horizontal scaling. So how does the concept of elasticity in terms of automatic scaling work? Well, Amazon EC2 provides you with a feature known as auto scaling, which does exactly this, and you can monitor the auto scaling using another Amazon feature known as CloudWatch, which is a service you can use to collect and monitor metrics around the auto scaling. And on the topic of auto scaling, how would you evenly distribute traffic across EC2 instances when they have been scaled out? Well, once again, AWS has you covered. There is another service known as Elastic Load Balancing, ELB. Now, although ELB and the auto scaling are two distinct services, they work in tandem in order to enhance application performance and ensure high availability. So now we have the hardware scaled and load balanced, let's move into some of the software realm. Let's say within EC2 we have an auto-scaling group of various EC2 instances that are hosting various apps, for example App A and App B. Now these apps from a software architecture perspective, when communicating with each other, can be one of two ways. The first architecture is known as tightly coupled, where if App A fails then App B would directly fail too. However, there is a second approach to this architecture known as loosely coupled, which basically adds a buffer or message queue in between App A and App B. This message queue covers all eventualities, such as if App A sent a message to App B, but App B was broken, then the message would stay in the queue, aka the buffer, rather than being lost or failing completely. And this same principle applies vice versa. If App B sent a message to App A and App A was broken, then the message stays in the message queue. Now let's dive into the different types of message queues offered by Amazon. There are two main types, the first being Amazon SQS, Simple Queue Service, and the second being Amazon SNS, Simple Notification Service. Now, whilst these two services might sound the same, there is a key distinction between SQS and SNS. SQS, the key letter is the Q, which stands for a queue of messages that go into the buffer or message queue, where they can be stored, sent, or received until the process or app that requires them needs to do its thing. In other words, picture a message board where orders are waiting to be processed, aka in the SQS queue. Now, on the other hand, the SNS, the key letter being N, is a notification service, meaning messages don't sit in a queue, they need to be sent in real time. In other words, right now, such as a message board with orders ready for collection. And here is a AWS Cloud Practitioner exam bonus tip. Think of the SQS service as a pull-based service and the SNS as a push-based service. And there is actually a third service that Amazon offers, which is event-driven, and this is known as Amazon Event Bridge. And the idea of Event Bridge is that it can route events from the application, such as an order or a payment, and route it to various apps, whether that be Amazon or a third party, and it can even route it to Amazon services such as Lambda functions, etc. An important keynote for your exam here is that whilst these AWS services sound the same, they are different in their usabilities and capabilities, although some may overlap. Also, some of these icons at time of making this video, October 2025, may have changed when you are watching this, or some of these services may work slightly differently, but this is accurate as of its time. Now this was just a brief introduction, and there is a lot more services to add to this diagram. I will thus make a part 2 video, so please be sure to like and subscribe to help support this channel's growth. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.